Variation and problem solving. One kind of variation is direct variation. That's when two things are related in a way where the bigger one thing gets, the bigger the other thing gets. So if one thing is twice as big as it used to be, the other thing is twice as big as it used to be. So we would say that y varies directly as x, or y is directly proportional to x, or sometimes we leave out the word directly and just say y is proportional to x. But mathematically, we can express that as an equation that looks like y equals k times x. So if y is proportional to x, y is equal to some particular number times x. And that particular number is what's called the constant of variation or constant of proportionality. It could be 3, could be 10, could be 1/2. So equations like this would include, for example, y equals 3x, or y equals 0.5x, or it's possible for y to be proportional to not just x, but maybe x squared, or x cubed, or the square root of x, or something like that. So an example of that would be y equals 20 times x squared. There y varies directly as the square of x. So here's an example of a kind of problem you might have to do. Y varies directly as x. Find the constant of variation, that would be the k, and the variation equation, that would be the whole equation with that number in it, if y equals 10 when x equals 4. So there's 3 steps. Step 1, write the equation using letters. So when it says y varies directly as x, you would translate that into an equation, y equals k times x. Step 2, take the numbers that they gave you for y and x and plug those into that equation and then solve to find what number k has to equal. So I'm putting 10 in for y and 4 for x. 10 equals k times 4. To solve that for k, I need to get k by itself. I need to go from k times 4 to just plain k. And I do that by dividing both sides of the equation by 4. So k equals 10 divided by 4, which you could either write in decimal form as 2.5, or in fractional form as, well, 10 over 4 simplifies to 5 over 2, 5/2 in lowest terms. So now that we know what k is, we're ready for step 3. Rewrite the equation, but with that specific number in place of the letter k. So instead of writing y equals kx, now we can write y equals 2.5x, or y equals 5/2 x. Now what about inverse variation? If two things are inversely proportional, or vary inversely as one another, that means that the bigger one of them gets, the smaller the other one gets. Like if one of them becomes twice as big as it used to be, the other one's only going to be half as big as it used to be. So y varies inversely as x, or y is inversely proportional to x. We can write an equation for that that looks like this. Y equals k over x, k divided by x, where k is just some number, some constant, the constant of variation or the constant of proportionality. For example, y might equal 12 over x, or y might equal 3.6 over x. And just like with direct variation, it's possible for y to be inversely proportional to not x itself, but some power of x. X to the second power, or x to the third power, or maybe the square root of x, or something like that. So you could have y equal to 1,000 over x cubed. Y would then vary inversely as the cube of x, x cubed. So here's an example of that. Y equals k over x is the kind of thing we're dealing with when we see y varies inversely as x. So when you see that, you can immediately write an equation that says y equals k over x. Step 2, plug in the actual numbers they give you for the variables, y and x, and then use that to solve to find k. So here they gave us y equals 10 when x equals 3. So I'm going to put 10 in for y and 3 for x. So 10 equals k over 3. Now I want to go from having k over 3 to just k. How do I go from k divided by 3 to just k? I undo the divided by with multiplication. I multiply both sides by 3. So then 10 times 3 would be 30, and k over 3 times 3 would just be k. So it turns out that k equals 30. Now we just go back and rewrite this equation, but with the number we just found in place of k. Instead of y equals just the letter k over x, we write y equals 30 over x. Now for some applications, some word problems. To solve these, before we do that, sorry, I had another example before we got to the applications. Y varies directly as the square root of x. Find the constant of variation and the variation equation if y equals 12 when x equals 4. Step 1, write the equation of variation using letters. So here it says y varies directly as the square root of x. So how would you translate that into an equation? You would write y equals k times the square root of x. Y equals k times the square root of x. Step 2, plug in the actual numbers they give you for y and x. Y is 12 when x is 4. So 12 equals k times the square root of 4. Now the square root of 4 would be 2. So really this is telling us that 12 equals k times 2, 2k. And now dividing both sides by 2, k equals 6. Now that we know what number goes in place of k, we can rewrite the equation as y equals 6 times the square root of x. And here's an example where there's more than one variable involved in the proportionality. Here it says y varies jointly as x and w. So that means there's two different things that y depends on, x and w. The way we would write that is just y equals k times x times w. Now to find the constant of variation and the variation equation, if y is 12 when x equals 3 and w equals 5, put those numbers into the equation. 12 equals k times 3 times 5. Of course, 3 times 5 would be 15. So 12 equals k times 15, or 15k. Now solve for k by dividing both sides by 15. 12 divided by 15, you could either write as a fraction. In lowest terms, it would be 4/5, because the 12 and the 15 can both be divided by 3. Or you can write it in decimal form as 0.8. 12 divided by 15 is 0.8. So now we can go back and rewrite this equation. Just write the same thing, but instead of the letter k, we'll write the number 0.8. Y equals 0.8 xw, or if you like the fraction version, y equals 4/5 times x times w. So I'm going to save the applications for the next video. come back to that to see you using this variation equation system to solve some actual application problems.